Okay, let's learn how to rewrite a Fourier series in a new, faster, and more accurate manner for programming entities to use. Right here, we have an infinite signal here, which you commonly see in Fourier series. The question is, do you want me to write this in terms of an infinite Fourier series, or would you rather write it as a function like this? So if you go to your calculator or some graphing utility and you graph this function, y equals this function, you will get this signal right here, this infinite signal. This is -1 to the absolute value of the integer value. This is the integer value of -x minus 1. Okay. There's one example. If we want to adjust this to the square wave signal, infinite signal like this, we notice that we could use this formula right here instead. This is this that we wrote up here. There's a +1 and then all divided by 2. Basically, we're shifting it up and dividing by 2 so that we can just get a square wave infinite signal right there. All right. These are two examples of using creating infinite signals without you having to use Fourier series. Of course, these do not have in any way any kind of Gibbs phenomena occurring at the discontinuities, so the accuracy of these are absolutely perfect, and you don't have to take like 20 terms of Fourier series to get an approximate value. These are perfect values. Let's take a look at a new function here. Here we have a function x minus integer value of x. If we do y equals this on a graphing utility, we will get the sawtooth wave that you see here, like this, infinite signal, of course. And again, a nice little compact, fast method of analyzing a signal, infinite signal, without having to use Fourier series. Let's look at a few more examples. Actually, if we take this example and we square it, what we get is we get parabolas here, infinite parabolic infinite signal here. That's if we square it. If we cube it, x minus int integer value x squared, x minus integer value x cubed, you'll get cubic functions. If you take the square root, you'll get the square root function, an infinite signal with square root functions. Here's the sign of that argument right here, sign of x minus intx. You'll get sine functions, infinite signal right there. Natural log, you get natural log functions right here. And finally, 1 over x, 1 over this, minus 1, just to shift it down a little bit so it touches the x-axis. You'll have 1 over x infinite signals here. There's a multitude of equations here that we are learning how to use that will generate a signal, infinite signal, that normally we would need infinite Fourier series in order to write a mathematical equation for this. An infinite Fourier series, of course, has the problem again of Gibbs phenomena occurring at the discontinuities. So that causes errors, and also it cannot be, there's no way an infinite Fourier series, or even 20 terms of an infinite Fourier series, can be as quickly utilized by a program as these equations, as you will see when you try to use them. Okay, anyways, have fun with those, and we'll talk to you later.